Hello everyone, welcome to Science Prodigy. We will be starting factorization of class 9. Before we begin, I would like to tell you that please subscribe the channel for your own benefit because I will be covering all the chapters of physics, chemistry and mathematics of class 8 and 9. So let us begin with factorization. Now what is factorization? First of all, let's go to the bit of introduction part of it. So what is factorization? How do we get a factor? If we go for normal system, that is, for example, if we take an example, that is 42. Now how do we express 42? We express 42 as in the product of prime numbers, we can actually go for 2 into 3 into 7. So the moment I write down 2 into 3 into 7, so I am trying to express 42 as the product of prime numbers. Now each of these numbers are the prime factors of 42. So if I am going for this one, these are nothing but the prime factors of 42. Okay. So this is how we go for factors. Factors are nothing but certain irreducible forms of an expression. Means for algebraic expression, they are the irreducible algebraic expressions which are written in product form. That is, we always write the factors in a product form, in a multiplicated form, so that upon the product of two or more such algebraic expressions which are irreducible. Irreducible means you cannot reduce them to any more further factors. They will give up the original expression. Let us take an example to understand what I tried to mention. That is, let us get a clearer picture of what I tried to say. For example, if I go for a very simple example in the beginning, just to make you all understand that what is factor. If I go for 9x square minus 36, and we are asked to write this in the factor form. Factor form means into irreducible algebraic expressions in the form of products. Factors are always expressed in the multiplicated or the product form of irreducible, which cannot be further factorized. We cannot further factorize it to some more extent. Okay, so if we go for the factors of 9x square minus 36, in this algebraic expansion, the factor is 3x minus 6 into 3x plus 6. Each of these terms are irreducible. We cannot reduce them further. This is irreducible maximum time, and these are the factors. That is, 3x minus 6 is a factor of 9x square minus 36, as well as 3x plus 6 is also its factor. So algebraic expansion which are irreducible, described in a product manner or a multiplicated form, such that they are either 2 or more in number. So these are the factors, and that is how we go for factorization. So now we will be moving forward to factorization part, but before we start factorization, just remember one thing: factorization is the reverse process of multiplication. Okay, why is factorization the reverse process? Because these are the two factors which we have finally factorized 9x square minus 36 into these two factors. Now the moment I factorize this and I go for multiplication of this, I can easily obtain 9x square plus 18x minus 18x minus 36. That is, we obtain the original expression. So this is the multiplication of the factors that I did. So factorization is the reverse of multiplication. So starting with the beginning part, how can we go for factorization? By taking a common factor. So let's go for that. For a common factor, we need to go for checking the HCF of the two given algebraic terms in the particular algebraic expansion. That is, by taking out, that is also a form of factorization where we take the common factor, and the common factor has to be determined by going for the HCF of both the algebraic terms present in the algebraic expansion. So let us see certain examples of that particular type. factorizing these two, we have to go for the factorization by taking the common factor. So let us see the first one, 24x cube minus 32x square. We have to go for the maximum, that is the maximum common factor, or basically the HCF of both of them. So if we see in this one, the HCF of both of them will be 8 is divisible, 8 divides both 32 and 24. So 8 is the maximum and x square is common in both. So I am taking x square here. So this becomes 3x minus 4. So this is the common factor method for, so this is the basic common factor method for factorizing, where we take the HCF of both of them. Now for the second one, let us check this one, that is which is the maximum common factor in all three of them. It is 2 because all of them are divisible by 2. Now minimum is x among x, and for y also minimum is y. So 2xy is the maximum common factor, or 2xy is the HCF of all the three algebraic terms. Now we go for the product form, because factor form means only it has to be expressed in the form of a product. So then we go for this part. So this is our answer. If we go for the factorization of this part, we have to again go for the common factor method, which is the common factor that we can spot out. First of all, it is p minus 2q, which is clearly seen. Now this is 20, p minus 2q is common. Now we see the second most common factor, that turns out to be 2. So now we express the remaining part in the product form, which is 5 times of p minus 2q whole square plus 3 times of p minus 2q minus 10. So this turns out to be our answer for this question. Now the second type of factorization which we are going to go for is grouping of the terms. This is the most common way where we factorize. We always don't get a common factor. It is not necessary, but grouping of terms has to be done in most of the cases. So let us begin that how we can actually go for grouping them, and then in that particular group we have to find the common factor. If you see the example, you will understand it better. That is for the first one. If we see, it is ax minus ay plus bx minus by. So now the moment I go for grouping of the terms, I can either group ax and bx because they have the common term x in them, or I can go for grouping ax with ay because they are having the common term a, but it does not matter, because at the end of the day, if you do for grouping having a common term, that is enough. At the end it will give the same result. That is also that I will be showing. So if I go for taking x common here, I will find that it is nothing but a plus b, and in this one, the second part, if I go for taking minus y as common, this is also a plus b. So our answer is a plus b times of x minus y, because a plus b is common in both. If I take a plus b as common, that will be x minus y, which is coming up. Now if I go for grouping the other two ones, what will happen? It will yield the same result. Let us check it out. That is, if I go for grouping, instead of these two, if I go for grouping the other parts, that is, I go for grouping ax ay and bx minus by. So a is the common part here, x minus y coming up. Here b is the common part, so x minus y resulting. So x minus y is common to both, taking x minus y. So x minus y is termed with a plus b. So it yields the same result. The only thing is you have to go for grouping such that it is having something in common. So now we will be moving on to question number 2. You can try it on your own by pausing the video and then follow it along with me. That will be far more better. So now the part 2 is x cube plus 2x square plus x plus 2. So for moving on to the part 2, we can actually see that we can go for grouping these two. The maximum factor, the maximum common factor which we can get for this grouping is x square, we have to go for the maximum common factor. So taking x square common, this will be only x plus 2 because x square has been taken in common, plus for this 2 we can only get a 1 times of x plus 2 because there is nothing extra common in these two. So 1 is common, x into 1, 2 is to 1. Now x plus 2 is common to both, x plus 2 taken in order, x square plus 1. So this is our answer for question number 2. Okay. So now we will be moving forward to question number 3, which is AB times of x square plus y square plus xy times of a square plus b square. Okay. So I am rubbing this off and moving to question number 3. As for question number 3, if I actually go for multiplying these brackets as well, what will I get? ABX square plus ABY square plus A square XY plus B square XY. Now we have to go for the grouping of terms. So because they were already grouped, I can understand that this AB and XY pair will not work because they were not getting grouped. So I have to take the other groups. That is, if I go for taking AX common from these two, and from here if I go for taking BY common, we can get the factor form. Let's check. That is, if I take AX common from this one and this one, we have BX plus from this one we have AY. Now going forward to these two parts, we can see that BY is common taken. So the answer is AY plus BX. So we can actually see that yes, the grouping has been done properly because BX plus AY is coming common in both. Taking BX plus AY here, the remaining part turns out to be AX plus BY. So this is our answer. Okay. So as you can see, the next two questions are here. In this one, for the first one, if we go for actually multiplying this part, it turns out to be A square plus AB minus AC minus BC. Now what can we take as common? Because A cannot be taken in common from this part, so we can go for taking these two and these two because we can see B is common here and A is common here. So taking A as common, this one will be A minus C, and from this one if I go for taking B as common, we get the common factor A minus C in both of them. So our answer is A minus C taken common, now A plus B. So this is our answer for this part 1 question. Now moving forward to the part 2 question, which is x cube minus x square plus ax plus x minus a minus 1. So what can we go for grouping? If I take these two for grouping, because there is maximum x square here, this can be a possible good grouping. So I get x minus 1. Now again taking this one and this one, because we can go for getting a x here, we can go for getting a common here. So if I go for getting this a common, again I am seeing the pattern coming up, that is x minus 1 arises here. Now remaining part is also x minus 1. So if we multiply and both x minus 1 has the common factor 1. So our answer is x minus 1 times of whatever we got as common, that is x square plus a plus 1. So this is our answer for the second question. As you can see the two questions here, the first one is a square plus b square minus 2 into in bracket ab minus ac plus bc, and in the second question it is 1 minus of b minus c whole square. So the given task is to factorize them. You can do it on your own and then follow it along with me. So now for the first one, we can see that a square plus b square minus 2ab minus twice of minus AC plus BC. If I go for doing it till this much, I am just liberating AB out of the bracket so that I get a minus 2AB and the remaining part stays inside the bracket only. So this part becomes a minus b whole square for me. Now minus 2 here. In both of them, from both of them, what can I do to get the a minus b part? Here as well, I can get the a minus b part if I actually take minus c common from both. Just check it out. If I take the minus c common part from both, this minus c has been taken, so a stays as it is, and because minus c has been taken, this part becomes a minus b. So why was my intention to take a minus b from this bracket as well? So that I can get this a minus b and this a minus b as a common, and we can achieve the factor form. So if I take the a minus b part as common, I can easily see that this part is the remaining a minus b, and from this part, this is minus 2 into minus c, that is plus 2c. So this is our factor formed for the first question. We just had to go for this, and then we had to go for trying to get this a minus b here. Now the second question, which is 1 minus of b minus c whole square. Now if we look at the second question very carefully, we can see that it is nothing but it is of the a square minus b square form. That is, if I consider it to be 1 square minus of b minus c whole square. So what is the a square minus b square formula? A plus b into a minus b. So that gives us in the product form only if I go for a plus b into a minus b. So the part is a plus b, where b is nothing but b minus c part, into a minus b. So a minus b means this becomes the answer. Okay. Now the next set of 3 problems are on the board. So as you can see, the first one is a times of a minus 3 minus b times of b minus 3. So do it on your own, pause the video, do it on your own, and then check it out along with me. So for the first one, if I break this particular factored thing, it is a square minus 3a minus b square plus 3b. Now if I go for taking a square minus b square separately, because what I can see here is very important, that I can take 3 common from this. I take 3 common, or rather if I take minus 3 common, it will be more helpful. This one will be a minus b, because minus 3 has been already taken into common, it is a, and because here it is plus b, so here has to be a minus, so that minus minus becomes a plus. Okay. So why did I go for this one is very simple, because the moment I break a square minus b square into its factor form, it will become a plus b into a minus b, and a minus b then can be taken common from this part. Okay. So let's check it out so that we understand it. Okay. So a plus b into a minus b, separating this, minus 3 times of a minus b. The moment I take a minus b as common, we get a plus b minus 3 here. All right. So this comes out as our answer. It was very simple. Why did I take up minus 3? I hope you all have got it now. Because a minus b has to be generated right here. So for that purpose, because I am already getting a minus b from a square minus b square, I have to take minus 3 so that a minus b comes in, and taking the common factor a minus b and factorizing it becomes more easier, because factorizing by getting the common factor is a great thing, because it becomes factorized in minimum number of steps if you are able to find out that particular grouping which gives you the common factor and the factor is ready. Okay. So you can copy this down. It's very important that you just don't see the problem, you are just seeing and it's done. No, you can actually sit with a pen and paper, because it is maths and you have to do it along with me, and it's far more better if you are doing it before me. At least you are attempting to do it before me, and then if it happens and you tally it with my one, that's great. If it does not happen after your attempt and rethinking, you can actually see it and then do it along with me. Hear me out, do it along with me, so that these sort of problems never become a hindrance. You just see them and you crack it. Okay. So I hope you have copied this one. Copying is very essential. I am doing good problems for you all, sorting out the good problems so that it can help you for your exam purpose as well. So now for the second question, 3x to the power 5 minus 48x. I hope you are going to attempt this part 2 question before me. 3x to the power 5 minus 48x. What can we do? The first thing that comes to our mind is we can go for taking 3x common here. The best thing that comes to our mind, because x can be easily taken, x is the minimum part of this particular part available. So x can be taken, and 3 is also, that is 48 is also divisible by 3. So let us take 3x first. And the moment I think I rubbed off a question, no matter what, let's continue. 3x is taken, and then we get x to the power 4 minus, if we go for factorizing this part, it is nothing but 16. Let us observe the trend. 3x times of x squares whole square minus 4 square, isn't it? X square whole square, and this is 4 square. Why am I doing this? I can get the factor form, that is 3x square minus 4 into 3x square plus 4. But now, whenever we factorize, we have to go for the irreducible factors, that is, they cannot be reduced further. But as I can see, x square minus 4 can be reduced even more further, okay. So 3x into x minus 2 into x plus 2 into x square plus 4. This is our final answer for the question. I am writing down question number 3 actually again. So as you can see, the question that I have rubbed off by mistake, I have written it once again. It is twice of AB plus CD minus A square minus B square plus C square plus D square. So how do we factorize this? This particular part is in plus C square plus D square. So if I consider this part, C square plus D square, and I am already splitting out 2AB and 2CD. I go for 2CD part. I take only this part. Now, if I go for a minus, taking a minus common out of this A square and B square, this part becomes A square plus B square. And now 2AB needs to become minus 2AB because the minus has been taken as a common. So this reduces to C plus D whole square minus of A minus B whole square. So if you can identify the form, this is nothing but x square minus y square form, and this will help us in factorizing it all together. So the answer becomes x plus y, considering this as x and this is y, into x minus y. Okay. So here comes the answer of the question. So the next two set of questions are here on the board. The first is x square plus 4. The second one is x to the power 4 plus x square plus 1. So let's start with the first one, x square plus 4. In this question, we have to go for making certain adjustment. How? Let us check it out. This first part is x square. The second part is 2 square. Okay. So now, if I can go for making it a square minus b square form, that would be very much helpful. So I can see that it is x square plus b square. So if I attach one more part to it, that is 2 into x into 2. Okay. So I can see that it is x square, that is a square plus b square plus 2ab. If I add 4x to this, okay, this is 4x, but as because I added this 4x here, but it was not supposed to be here, so I can go for an adjustment by even subtracting this 4x. So it remains neutral. The same expression is here because plus 4x minus 4x, this becomes a 0, right? So now if I can go for the particular adjustment, this will become x plus 2 whole square, and this part will become a minus 4x. So the question reduces to, in the question it was actually given that it is x to the power 4 plus x square. I just wrote it wrong. This one will be the square of x square, and this part hence will become 2x square, making it 4x square. Okay, so it is just x to the power 4, that is it is x square's whole square, and for that we have to go for 2 into a into b minus this part because we have added 4x square and this was not supposed to be here. So we can see that it is in the form of a square minus b square, right? This is a square part and this is the b square part. So we can easily factorize it as this into c square plus 2 minus 2x. So we obtained the factors, right? Now moving forward to the next question. The next question is x to the power 4 plus x square plus 1. So if I say the next question, we can again go for the same thing, the same adjustment here. Here instead we have been already provided one x square. So if I consider this to be the whole square of x square, for question number 2 I am doing, this is x square's whole square, this part, this one is 1 square. Now what do I need extra? A 2x square into 1, and as because 1x square is already provided to us, we have taken 2x square, so 1x square needs to be subtracted so that it stays as x square only like the original expression was. So this part now becomes x square plus 1 whole square minus x whole square. So again we are able to reduce it to the a plus b into a minus b form, and here comes the factor form. So today we have discussed ample number of questions. You can practice them on your own afterwards as well, so that you actually get accustomed to the practice of factorization. You need to practice more sums on factorization. In the next video, I will be continuing factorization as well. So stay tuned, keep studying and keep watching. Thank you.